Now let's look at merge sort. So far we've covered the basic sorting algorithms like bubble sort, selection sort, and insertion sort. So now we're going to take a step further and explore some more advanced and efficient sorting algorithm, starting with merge sort. So this algorithm like merge sort, quick sort, and heap sort are often used when we need to handle large data sets because they sort of offer or perform better in terms of term complexity. So starting with merge sort, it is a classic example of a divide and conquer algorithm, and which what that means is that it breaks down a problem into smaller sub problems, then solves those and merges the results back together. So if you have, let's say this is the bigger problem that we have, then it's going to be split, let's say into smaller problems. So if it split them maybe into two smaller problems like this, then now we solve these two smaller problems, and after solving the two smaller problems, now we go ahead and have our merge them back together to get the bigger problem. I mean the solution. So what we have here is, let's say this is the problem that we're dealing with. So that's the problem that we're dealing with. Then we split it down into sub problem. So let's say this is a sub problem that we have here, and everything is we split them down like this. Then we solve these sub problems, and then we get the final, let's say final solution here, like that. And that's basically, yeah, how it works. So let's see how merge sort works in a bit more detail. And so the first thing that we do with merge sort, like you've seen, we basically divide. So if you have a list of, let's say a list of numbers that we're trying to sort, we're going to divide the list into two halves. So we divide the list into two halves. And after dividing the list into two halves, we're going to basically now conquer by recursively sorting both halves. So basically conquer by recursively sorting both halves. So after sorting the both halves that we have, we are now going to merge the two sorted halves into a single sorted halves. So we basically merge. Yeah, let's just say merge instead of typing everything. So we're now going to merge the two sorted halves into a single sorted list. So again, this is what we mean: divide, conquer, and merge, and that is basically what we've demonstrated here. So this process continues until we are left with individual elements, and those individual elements will end up being trivially sorted. Then we can just match them back together to the correct order. Now let's look at a practical example of an array that we can try and sort. So let's say we have an array here, and it has elements. Let's say uh, 38, 27. It has maybe a 43 there. It could have a 3, 9, and let's say 82. And let's give it a final element, maybe 10. So we have an array like this one, or a list like this one, and we want to sort such a list. So the first thing we're going to do, we're going to divide this list into two halves. Yeah. So let's go ahead and we divide the list into two halves. And after, if we divide it into two halves, this is what we're going to have. So we're going to have the first half having maybe 38, then it will have 27 and 43. That's going to be the first half. And then the second half of this list is going to now have 3, it's going to have 9, it's going to have 82, and it's going to have 10. So we have these two halves now. Then now we're going to continue dividing these halves basically until each sublist contains one element. So we're going to basically divide them down until each sublist contains one element. Then we can start merging the smaller sorted list back together until the entire list is sorted. So it's just this process. So we just break everything down, then we merge the sorted parts. So now that we've sort of seen in a high level how you would approach such a problem, now let's write some code that is going to help that they're going to use to just implement this two. Let me just add a comma here to show that these two are different. Yeah, like that. So let's go ahead and write some code. We're going to do the implementation in Python, but again, it's going to be sort of easy also to implement in any other programming language of your choice. So now I'm going to just reduce the font a bit. So let's declare a function here, and we're going to call it merge sort. Merge sort. Then, of course, it checks in the array that you want to sort as a parameter. Then now after doing this, we're going to sort of now start by doing a few things. So we're going to start by declaring, or rather checking the length of the array, and if it's greater than one. So that means that the specific list that we're trying to check has to have more than one element for us to proceed. So we're going to check if the length of this array that we have here is greater than one. And if that is the case, we're going to go ahead and divide basically now. That's the first step of our divide and conquer algorithm. So we're going to divide, and we're going to just check the length of the array, and then we're going to divide by 2. Again, in this case, we have to use the floor operator, since it's going to sort of, if you use a single and basically a single forward slash, and it has an odd number of number of items, it won't get all the elements the way you want them. So we just store this in a variable called mid. Then we're going to basically now, this is us splitting it into two halves. So we're going to have a left half, and this left half will just have the array at index mid, like that. So you're going to get that subarray. Then the other subarray is going to be stored in the right variable, and this is going to have the next half, like that. So after getting this, then we're going to now start implementing some sort of recursion here in terms of how we sort them. So we sort everything recursively here. So we're going to do merge sort, and it's going to take in, one of them is going to take in the left. I should be closing this. Then we're going to also sort the right, like that. So after doing this, we're going to go ahead and look at the next step here. And the next step for us now is going to be, we're going to declare three variables, right? We're going to initialize basically three variables here. Let's have, I call them I, J, and K. We're going to declare and initialize them to 0. This basically are going to be three indices, or three index variables. And how they're going to work is, we're going to have I to track the current index of the left array. Then J is going to track the current index of the right array. And then finally, K is going to track the current index of the original array that we had, where elements will be placed basically during the merge process. So in K. Then now from here, we're going to start by basically, we're going to have a while loop. Then this while loop is going to run as both the left and right arrays have elements that haven't been matched since the first step that we're starting with. Then we're basically going to continue that process and ensure that we're within the bounds of both of the arrays, the left array and the right array. So we're going to have a while loop here. We just say while I is less than the length of the left, and J is less than the length of the right. So while that is the case, we're going to go ahead and check which element from the left or right subarray is smaller. So I'll do that. We just have an if. They're going to check if the left at index I is that's okay, less than right at index J, And if that is the case, we're going to basically store this. Remember, we're dealing with the array k, so we're going to have left at index I at array k. Going to have I here. Then we're going to just increase I by 1. So I plus equal to 1. Else, if that's not the case, we're going to take the one at j is the one that will go to k. So array at key index k, we're going to have j here. That's now from the right. Then we're going to also increase j by 1. So j plus equal to 1. And also going to have now, outside of this, we'll have k as we're going to increase basically k by 1 as well. So basically what you're doing here, what you're checking here is if the left at index I is less than the right at index j, the smaller element from the left subarray we're going to place that basically in the original array. And that is what we're doing here. Again, the original array at index k, as we've already sort of like started from here. Then we're basically going to do the increments by 1. Otherwise, if that's not the case, we're going to take the element from the smaller element from the right subarray. We're going to place it in the array basically at index k as well. Then so k after k is we basically increment the k after each element to basically move to the next position in the original array, since we're getting each of the elements sorted and storing it in an array. So the next step that we're going to do from here is, let's go ahead and we're going to have another while loop here. And we're basically going to check for I less than the length of the left. If that is the case, or rather while that is the case, we're going to take the array at index k, and we're going to basically store the left I here. So we're going to have the left at index I here. Now after this, we're going to increment both I and k. So I plus k, then we also have not k but rather 1. Then we do the same for k. So k plus equal 1, like that. So this loop that we've done here basically runs if there are any remaining elements to the left subarray that haven't been added to the original array. Then it copies the remaining elements from the left basically into the original array, that we have here. So we're also going to have another loop here. And this loop is going to check for j for the right side. So while length of the right subarray, then we do the same that we've done for the previous one. So we just take at index k, looking for an equal sign. Then this is going to be right, not left, at index j now. Then we increment both j and k. So j plus equal to 1, and k also we increment it by 1, like that. So again, the same explanation as what you have already done before. So basically, what you've done up to this point is trying to implement the merge sort, And what you can do here is we're going to go ahead and let's return the array after everything here. So it's basically return the array that we have already sorted, and let's call this function. So we've called it merge sort. Okay, I want to print the output. So I want to print the output calling merge sort, and we're going to give it an array. Let's go ahead and copy the array that we have here, since this wasn't sorted. And let's place it here. I'm going to remove one of the square brackets, like that. Okay, let's run our code and see. So we're going to just say python3 mergesort.py. And once we do this, 3, 9, 10, 27, 38, 43, 82. Yeah, our array is basically sorted. So to go over this process, it's what we've already explained here. We're dividing the list into two halves. Then we conquer recursively by or rather we conquer by recursively sorting both of the halves, and that is what we're doing here. And we are going to merge them at the end. So we're conquering everything. Then this is the entire process that we're going through to basically sort each of the elements in the subarrays and merging everything together to basically have a sorted array at the end. So this merge sort algorithm that we've done, that we've looked at, it runs in O of it's in terms of the term complexity. So let's write that here, and let's use a white. So the term complexity of this is O of n log n, and this is O of n log n time in terms of the time complexity, and it's more efficient than the other algorithms that we've discussed before. And basically, it's because, as you've seen, we're basically we're splitting the problem down, so the problem keeps on reducing in size as we move, which makes it efficient for we're dealing with a really large data set. This would be more efficient than what you were doing earlier by iterating through the entire array. So you have to basically visit each of the elements like sometimes twice. So this is more efficient than the ones that we've had before. And in the next video, we're going to look at quicksort algorithm.